Alright, Common Core Algebra 2. So we are going to look at 5.5 Part 2. So remember, Part 1 was about long division, kind of a challenging concept. Part 2 is going to be a look at synthetic division, which, if you remember earlier in this chapter, we did something called synthetic substitution. They are basically the same thing, but now synthetic division is going to be really helpful when we start factoring. So after we talk about synthetic division, we're going to talk about what the factor theorem is. Okay, so first of all, synthetic division is just going to be a quicker way to divide polynomials. The only limitation is that it has to be linear, meaning it has just an x term, so something like that, and you also know the coefficient of x has to be 1. So like x plus 2 would work. In this case, you'll also notice, since it's minus here, the c value is really important to us. Here, c would be negative 2, so it's always opposite. Think about the value that would make this 0. So we'd have to plug negative 2 in for x to make this term 0. If it was something like x minus 4, then c would be 4. Okay, so c is going to be really important when we do synthetic division. And you already hopefully have these steps written down somewhere in your notes, but just as a quick recap, you're going to first write the coefficients in descending order of degree. We should actually write of degree. So remember, that means your power. Okay, so whatever has the highest power, that coefficient has to be first, the next highest power, the next highest power, and so on until we get down to our constant. Remember, you can't skip any terms. So if there's like an x cubed and then an x squared and then a constant, you need to put a 0 in for the x. We have to have that place filler. And then also, to finish setting up the problem, you're going to set c to the left in a box. Okay, bring down the first leading coefficient, multiply it by c, and write that under the next coefficient, and then this is where we just start repeating ourselves over and over. You add and bring down the result, multiply and write that under the next coefficient again, and then just repeat c and d over and over until we've done them all. Now that sounds like a lot, so to show you an example here, okay, I need to start by writing my coefficients in descending order, remember, of degree. So x cubed is my highest, so my first coefficient is a 1. Now I need my x squared coefficient, which is a 3. Now I need my x coefficient, and you'll notice there is no x here, so this is an example of one where I need to put a place filler in as 0. And finally, my constant, and then outside the box to the left, I'm going to write c, which in this case is a negative 4. That's really important. Okay, first step, bring down your first coefficient. So we're going to have 1. And now I'm just repeating the steps over and over. Negative 4 times 1 gives us negative 4. I bring down, or I add, and I get negative 1. I multiply, I get positive 4. I add, I get 4. I multiply, I get negative 16. I add, I get 0. Okay, and now in this case, that 0 is going to be really important. It's not always going to be 0, but that's going to tell us something really valuable for what is called the factor theorem. Okay, if f of c equals 0, then x minus c is a factor of f of x. And likewise, if x minus c is a factor, then f of c will equal 0. So basically, we just said that works both ways. Now here's why that is important. If this number is 0, then that means f of c, f of negative 4, is 0. And so that's something called the remainder theorem, which we've talked about before in the past. We covered it really quickly, but that's not the important piece. The important piece is that this is 0, which means x plus 4 is a factor. So if I have x cubed plus 3x squared plus 16, and I tell you to factor that, that can be hard to factor, because even if we looked at our factor trees, we don't have any process for that. There's not any way for us to factor this. But now, because of synthetic division, because this is 0, I know that x plus 4 is one of my factors. And if I do synthetic division, these values right here are going to tell me my other factor. So since this was an x cubed term and I divided it by an x term, that means here is an x squared term. So I have 1x squared from that first one. These are basically your coefficients for your other factor. And I'm going to have minus 1x, because I need to decrease by 1 each time. So we have x squared minus 1x plus 4. And so these two now would be factored. Okay, we could look at other ways to try to factor this one. In this case, it's not factorable, so we'd be done factoring here. But this gives us a really valuable tool that if we can figure out if something is a factor, then we can do synthetic division to figure out what the other factor is. So as long as we know one factor, we can figure out the other factor through synthetic division. Okay, and that is it for those two. Synthetic division, again, is just a quicker way to do division, so instead of doing long division. And by doing that, it will help us factor our difficult polynomials that we can't necessarily follow that tree on. All right, we'll see you next time, guys.